Hi everyone, and welcome back to another episode of Dr. Kyle Explains, your YouTube channel where we go through GCSE science content quickly and easily. Today we're going to be going over the conservation of mass. Thank you to everyone who is subscribing to the channel, giving the video a thumbs up and telling everyone about it. It really helps the channel out. So without further ado, let's grab a pen, let's grab some paper, and please grab your calculator too. And let's go ahead and jump in. Okay, so some key content. The law of conservation of mass states that no atoms are lost or made during a chemical reaction. Now, this is also the same as saying in physics that mass cannot be created or destroyed. So what this means in chemistry, we refer to the conservation of mass as the mass of the reactants are equal to the mass of the products. You cannot create or destroy mass. No atoms are lost or made during the reaction. So let's have a look at an example. So here we've got a hydrogen chloride, the acid, plus an alkali, NaOH, and that gives us a salt and water. Now these are our reactants on the left-hand side of the equation, and these are my products on the right-hand side of the equation. And so if I had, let's say, 5 grams of HCl and 5 grams of NaOH, hopefully nice and easy we can see that is 10 grams on this side of the equation. And so what the law of conservation of mass states is that if there are 10 grams on the reactant side, there must be 10 grams made on the product side. Now, what we don't know is how much is made or how much is distributed. So, for example, it could be 5 grams and 5 grams again, or it could be something like 8 and 2 grams, or it could be something like 9 and 1 gram. But the total mass has to equal the same amount on this side of the equation. Okay, so let's have a look at some questions then of how they appear in GCSE. So these questions tend to be quite wordy and a lot of information. So you need to be able to read information from tables, and you need to understand that, remember, the mass is never changed. The mass of the reactants is always equal to the mass of the products. You cannot create or destroy the mass. So a pupil mixed hydrogen chloride, HCl, and NaOH in a reaction. Use the data from the table to prove the conservation of mass. 2 marks. So let's have a look here. We've got our container, and we've got here these 2 boxes. It says flasks before mixing. So here and here. And so what I'm going to do is I'm going to add 15.8 plus 13.4. And then when I do that on my calculator, so 15.8 plus 13.4 equals, that gives me 29.2 grams. So now I'm going to look over here. The empty conical flask after mixing is 4.5 grams, and then HCl and NaOH and flask after mixing 24.7. So here I'm going to go 4.5 plus 24.7, and so I'm going to do that on my calculator here. 4.5 plus 24.7 equals, hey presto, it comes out as 29.2 grams. And so I'm showing by calculation that the mass of the reactants are equal to the mass of the products. Okay, let's have another look at another example. So it says here, a pupil mixed HCl and Na2CO3 in a flask. The weight at the start of the reaction was 25.6 grams. After the reaction was complete, the weight was 23.2 grams. Now, straight away, that should raise some red flags, because obviously, straight there, it shows you that the conservation of mass has not happened. It's lost weight. So what's going on? People stated that the conservation of mass had not happened, and certainly it would appear that way. Explain why the pupil is wrong. Now, you have to remember, the conservation of mass is always true. It's a law in our universe. So the mass of the reactants has to equal the mass of the products. So what's happened then? So here is our answer. In the reaction, CO2 is formed. Now, why is that important? CO2 is a gas and so has escaped from the flask. Okay, and so what that means is the missing mass, so from 25.6 to 23.2, the missing mass is that CO2 there because it's a gas. And so if you imagine kind of like a conical flask here on the side, you've got your reaction going on inside it. CO2 is a gas, and so it would leave the flask, and therefore it would appear that the conservation of mass has not happened, that the mass has gone down, but because the gas has escaped from the flask, it should stay the same. And so what this means is if you had a closed vessel like this, with a top on the lid like that, and the gas couldn't escape, the mass would stay as 25.6. And so often what you need to identify is that there'll be some kind of gas forming. You'll say what that gas is, and then the gas escapes. Okay, let's have another look at a different question. So magnesium plus oxygen goes to 2 magnesium oxide. So a pupil burnt magnesium in air. Explain why it would appear that the conservation of mass has not occurred. So what's going on here then? So magnesium and oxygen are burnt and they form magnesium oxide. Just rewriting that equation, having a think. So if we had this, we had a strip of magnesium and we burnt it in the air, mass is going to be gained. Okay, so I'm just thinking, so that oxygen there is in the air, that must be adding to that magnesium to form magnesium oxide. So what we would say here is oxygen is in the air, which adds to the magnesium, forming magnesium oxide, which would appear to gain mass. And so if there was a reaction here, what would happen is, let's say the magnesium was 10 grams, nice and easy. This one, let's say for argument's sake, is 15 grams. Now you have to remember, if you're burning it in air, you're not going to be weighing the oxygen. And so obviously in this scenario, you're going to have 5 grams of oxygen, but you wouldn't know that because the mass is going to be coming from the air. And so therefore, because O2 is in the air, which adds to the magnesium forming magnesium oxide, and so it would appear that the magnesium would be gaining mass, forming magnesium oxide. Okay, so what we've done today then is we've explained the law of conservation of mass and we've calculated it for reactants and products. Thank you very much for watching. Please do go through my other playlists for more GCSE science content. And remember, if you ever need help with your GCSE chemistry, Dr. Kyle explains. Thanks very much. Bye-bye.